Question 5, we want to find and classify the stationary point of the following function. So, to find stationary point, we know that the derivatives are equal to 0. So, we have the partial derivative of f with respect to x equals the partial derivative of f with respect to y, which equals 0. So that is what we're going to use to find the stationary point. After that, we need to classify it, and we have a set of rules as to when it's maximum, min, saddle point, etc. So if we call a our second partial derivative of f with respect to x, square that, and then subtract the square of the second partial derivative with respect to y. If a is greater than 0 and fxx is greater than 0, then we have a minimum. If a is greater than 0 and fxx is less than 0, we have a maximum. And if a is less than 0, we have a saddle point. So they are our key facts, and this is for a three-dimensional function. So let's find and classify the stationary point. If we take f and partially differentiate it with respect to x, that will give us 4x plus 2y minus 2, and fy equals 2x plus 2y. They're both equal to 0. And now we can solve these two equations simultaneously. If we subtract the second from the first, 4x minus 2x is 2x, 2y minus 2y is 0, minus 2 take away 0 is minus 2, that equals 0. So here we can clearly see that x equals 1. And substituting this into the second equation, so 2x plus 2y equals 0, 2 lots of 1 is 2, so 2 plus 2y equals 0, so y equals negative 1. So this tells us that there is a stationary point, stat point, at the point 1 minus 1. So now we've got to classify it. Screen up a bit. Let's find out what a is. So a is equal to fxx, which is 4, and that's squared, minus fyy, which is 2 squared, and that is equal to 16 minus 4, which is 12. And this is greater than 0. So therefore we know it is either a minimum or a maximum. So, to find out if it's minimum or maximum, we need the second derivative with respect to x. So, fxx is 4, right, fxx, and that is greater than 0. Therefore, the stationary point at 1 minus 1 is a local minimum. And stop working. And that is how we find and classify stationary points of a three-dimensional function.